Best thing about living and working in Marseille?
Best thing about living and working in Marseille, one of the nice things is the weather. Of course, it's a very sunny city. We have more than 300 days of sun per year, so it's very nice to live here. It's nice because it's also a cosmopolitan city. We have Marseille is a very old European city with a lot of people coming from everywhere in Marseille, coming from other parts of Europe, but also coming overseas from other part of the Mediterranean Sea, from the Middle East, from the North Africa, from also the islands. And Marseille is a very, very cosmopolitan city. You can see and meet a lot of different culture and very interesting people. So it's nice. And what is nice for working in Marseille is the university. Aix-Marseille University is a very big university in France. We have a lot of research, a lot of neuroscientists. It's the second largest neuroscience community in France after Paris. So we have a lot of researchers that we can collaborate with. And the university hospital called APHM, for Assistance Publique des Hôpitaux de Marseille, is a very large hospital and it's a public hospital, university hospital, who takes care of a large population of more than 2 million of people. So, and it's the only university hospital for all this area, and so we have a lot of different patients coming from the region with different diseases, and a lot of research or excellence team on different diseases, and it's very very challenging and very interesting every day.
Nu när vi ska träffa Adil. Det känns som det ska bli väldigt spännande att höra på vad han har att säga om allting. Ja. Framförallt ska vi bara
få träffa honom.
Ja, bara träffa honom och så få ett perspektiv från Marseille, Frankrike.
Ja.
Istället för...
Nej, men Sverige som det alltid har varit. Ja. Jag har ju liksom grottat ner mig i Sverige, eller grottat ner mig, men jag har ju ändå, alltså i och med alla olika event, du har ju liksom varit med på flera event numera, så du är ju liksom inne i hela liksom MS-Sverige-svängen, känns det som. Nej, men nu bara få liksom se hur det ser ut i ett helt nytt land.
Ja.
Hur det går till här.
Det ska bli väldigt spännande.
Alltså jag tänker liksom att det ska ju vara jättespännande i och med att de har forskar ju jättemycket på det här, framförallt med de här nya magnetkamerorna som de har, och få reda på vad de kan göra. Men också lite som jag satt och skrev på frukosten i morse här. Ja. Att vad vi alltså jag tänker, alltså får du MS i Frankrike, hur liksom ser rutinerna ut då? Hur går det till och liksom hur ofta gör man magnetkamera och hur skrivs man in och liksom ditten och datten. Ja. Så det är jag jättenyfiken på också.
So, would you like to tell me a little bit more about the ongoing research here at the hospital?
At the hospital. So into our department, so we are in. So the neuroinflammation department is led by Jean Pelletier, who is professor of neurology, and the department try to develop two main research objectives. One of them is related to the lab where we are here, to CEMEREM. We work since 20 years ago on MRI to better understand MS, to better try to explain the disability in MS, to predict disability, and to understand the response to therapy, to know which patient will respond, which patient will not, etc. And so we develop a lot of, we use methods developed by colleagues worldwide, but we apply them to patients to try to have biomarkers of the disease, and in particular biomarkers of progression, which is the main issue of the disease, to have progressive patients. And so
you're already now answering my future questions here about the biomarkers.
Sorry.
No, it's good. Perfect.
Feels like I've been indoors for a century now. I'm dying to see sunlight. And when it shows to dissolve in it like I used to do as a child.
Tell me more about what we're sitting in front of.
So we are here in front of our most powerful MRI into the lab. So the lab have two MR systems. We have the E3T, with the system that you can find in clinics, but with here more research oriented. And we have a 70, which is a very powerful MR system that is FDA cleared and CE cleared to host patient and to perform images in patient, but it's there are very few 7T MR system worldwide. There are like 130 7T MRI over the world, so it's not a common system. And this system is dedicated, mainly dedicated to research, to better image the brain, to better image the spinal cord, and to try to have the best, most robust biomarker of progression for MS, for our case, but it's used also for other diseases, brain, but not only brain diseases, also for the muscle, for the skeleton, etc. It's used as well. And what I wanted to say, I forgot.
No, I'm just curious.
Nice.
For make it easier for, I think we're gonna come to that part as well. That for if you have like a person who's just got their MS diagnosis, comparing to do an MRI in a T1.5, and what's the
So the Tesla is the unit of the magnetic field, a unit of measurement of magnetic field. And if we want to compare, I say to my patient, but because we are here in the south of France, so I talk about south of France part, I say that the signal to noise ratio, the increase of signal to noise ratio between the 1.5T and the 7T is equal to going from the height of Notre Dame here in Marseille to the height of Mont Ventoux, so which is
okay.
So you know Mont Ventoux in Provence. So the gap is this. It's this gap.
Yeah, I understand.
This level of gap.
Yes. Oh.
So
And what do you see when you because just doing a normal MRI for me, when I have seen my pictures after we just every yearly visit we look at it, and now it's not dead, but it's nothing has happened for many years, but we check sometimes and
yes,
look.
of course.
But and when I see that pictures, for me it's like, wow, you can see everything.
Yes.
It's so much details, and when you just started to spin the picture, it was like, wow, you can see so much.
So because of this higher signal to noise ratio, we can do a lot of things. We can use it for a lot of things. One of the basic things that we can do is to increase the spatial resolution, of course, and to have more detailed images. And instead of 1 millimeter square into the image, voxel square, we can go to 0.5 millimeter or to 200 micron if we push the images to the maximum. So we can have like increase the resolution by 5 using the 70. So we can use this higher signal to noise ratio to improve the quality of the images. And with this improvement of quality of images, we can start to depict, for example, cortical lesions. Cortical lesions are not easy to depict on usual clinical field MRI, 1.5 or 3 Tesla, even 3 Tesla. It's very difficult to see them. We see the big ones, the ones who are mixed between the white and the gray matter, but the ones that are only inside the gray matter are very difficult to depict with conventional MRI. With 70, we start to depict them. We don't see them all, unfortunately. The resolution is it's still not enough to see them all, but we start to depict them and to see them and to understand how they appear, when they appear, how they evolve, what are their role into the disability of patient, and the increase of resolution allows to do that. With the increased resolution, we can see the central vein sign. For example, we can see the vein inside the lesion. We can see it in lower field, but it came originally from histological studies.
Before we look at the
images.
Yes, exactly. Do you think, or maybe you maybe know, is it possible with this T7 to vad heter förutspå?
Predict
progression.
So it was the second
in a very early stadium.
So it was the second interest of the increase of signal to noise ratio. It allows also to have different information that just increase the resolution. And for example, I'll take the example of the other nucleus that we can image on MRI, and in particular the sodium, because we work on sodium MRI. On 3T, we have techniques that allows us to have the total sodium concentration inside the brain, and so we can measure and see the total sodium dysregulation inside the brain, the accumulation in some part of the brain, etc. But the total sodium concentration reflects the sodium which is within the neuron, which is interesting to us because the sodium accumulates in neurodegeneration, but we also see the sodium which is outside the neuron, which is in the interstitial space. And this information is less relevant, for example, to image progression and neurodegeneration. With 70, we developed some methods to try to separate. It's not a real separation of and extra cellular sodium concentration, but we try with some technique to go to have the information of the intracellular part of the sodium accumulation and the extracellular part, and to have the real information that we need, the intracellular accumulation of sodium. And it's possible only with field from 7 Tesla and higher to 7 Tesla, because the techniques that are developed need this kind of field. So the increase of SNR is not just the increase of resolution. It allows also to develop new techniques, to see new things that we were not able to see before, and new development. Another nucleus is the phosphorus, for example. We know that in MS you have an energy impairment, an energy failure, because of a lot of things. It's because of the demyelination, so you have a reorganization of the sodium channels. You have also mitochondria dysfunction because of the microglia, because of the macrophages, etc. And so because of that, you have an energy impairment, energy imbalance in MS. And the energy into the body is the ATP. It's the vector of energy into the body, and the ATP, P is for phosphorus. And with 70, we can also develop, and we develop techniques to measure the ATP inside the brain and the ATP consumption, etc., inside the brain of patient compared to controls, to see if we can more precisely develop the imaging of the energy imbalance. And this energy imbalance, of course, is related also to neurodegeneration, and so to develop biomarkers of neurodegeneration. So the increase of SNR is also used to develop new techniques to try to depict progression in MS and to see that we were not able to see today.